JUnit as a habit, not an afterthought. JUnit basic annotations. Lab 2 overview. JUnit basic annotations. The goal of Lab 2 is to use basic JUnit annotations and to use all of them at least once during the course of Lab 2. There are 6 different basic annotations supplied by JUnit, so we will use each one of them in order to test the methods of our utility library we are writing. The code for the utility library is available from the course's GitHub account at https://www.github.com/GRG-001 JUnit as a habit. Before Lab 1, the code for the utility library should be downloaded to a computer. There are no changes to the code base needed for Lab 2. What you have already is sufficient. The following basic annotations will be explored at least once in code for GRG-001 JUnit as a habit utility application. Add before all, add after all, add before each, add after each, add test, add disabled. Each of these annotations will be used as part of a unit test class in testing the GRG-001 JUnit as a habit utility library. Each of these annotations may be used multiple times to illustrate various facets of their use. If any, please pay attention to annotation parameters that can be used to configure an annotation. Let's get started. Now, as we begin Lab 2, we'll have to get into a certain routine about our testing code from lab to lab. For example, we have worked up 5 test classes in Lab 1. In Lab 2, we are going to start Lab 2 by deleting all of them and recreating them. So let's delete all of them. Let's keep the test package. And let us create again a new objects tests class. Let us select everything in the class that's auto-generated and let us delete it. Then let us go to the website for the site, for the course. All right, we're getting there. It is Murphy's Law. Oh, there we go. Okay. Let's go to unit. Well, some hiccups. Let's go to unit test code, objects test.java, labs 2. And here we see 2 things. First, we see unified diff. We're gonna skip that, although you might want to study what's new. And we're going to go to full file. We're gonna click on copy. We're going to get back to our IntelliJ IDEA, press Ctrl V. And we're going to have the source code for our objects tests test class with the addition of material that we are covering in Lab 2, such as this. Alright, and that nicely corresponds with the green areas of our unified diff file. Alright, in the next clip we're going to start on looking at what's new for the basic JUnit annotations. So the basis of basic JUnit annotations are these several annotations. before all, or rather add before all, add after all, add before each, add after each, add test, and another annotation we're going to use, add disabled. Alright, let's start with the disabled annotation. When you see that a method within a test class has an add test annotation, it's a unit test. When you see that it also has an add disabled annotation, it is a unit test that has been disabled. So let's run our objects tests and see what happens. Alright, you can see that one of the tests was ignored. Out of 4, 3 passed. So the one that was ignored is the one we annotated with disabled. It was not run. Alright, let us now go on to the rest of the basic annotations in the next clip. Next, we're going to explore the add test annotation. Basically, every method that you want to be a unit test must be annotated with add test. And in the objects test class, we have exactly 4 unit tests. So whenever we run the unit tests, as of now, what happens is that JUnit runtime looks at a test class, parses it. If it has a nested inner classes, it parses them. It looks at add test methods. And that is what it runs as unit tests. See, it has run 1, 2, 3, 4. So both add disabled and add test annotations are very rudimentary and don't require us to spend a lot of time on them. In the next clip, we're going to take a look at before all and after all annotations in our objects tests test class. When we annotate a method within a test class with add before all, and we can have 0, 1, or more than 1 such methods, we will usually declare them as static. We will give them some name that is descriptive. And what we will do, we will essentially cause this method or methods to run when the test class, in our case it is objects tests, is constructed and instantiated. So, for example, if we wanted to initialize a variable, once for all the unit tests, in our case the 4 add test unit tests, we would do it here. And the mirror image of the add before all annotation is the add after all annotation that can annotate 0, 1, or more static methods within a test class. And we would use the after all annotation to clean up example, we initialize our private static integer I to 1 in the addBeforeAll method, and we basically reset it to 0 in the addAfterAll method. Of course, this is extremely simplistic. In reality, we would set up a database connection pool and tear it down, etc. Connect to something, close the connection, etc. And that is basically how addBeforeAll and addAfterAll annotations function. So addBeforeAll is invoked for all unit tests once and applies to all the unit tests when the test class is constructed. And the addAfterAll annotation is invoked once when all the unit tests of a test class have finished running. Alright. In the next clip, we are going to explore addBeforeEach and addAfterEach annotations. So in this clip, we are going to explore addBeforeEach and addAfterEach annotations. You will notice that they are not static, so they are instance methods. I mean, they annotate instance methods, pardon me. And also you will notice that we can place them in the top level test class, or we can also place them within a nested class that we're using for readability. So we can either place them in within the top level class or within a nested class, or both. And what methods annotated with addBeforeEach and addAfterEach do, and there could be 0, 1, or more. They basically run, addBeforeEach runs before each unit test runs, irrespective of whether the unit test is placed in the top level class or within a nested class. And addAfterEach runs after each unit test, irrespective of whether the unit test is placed within the top level test class or within a nested inner class. However, when we have this addBeforeEach and addAfterEach within a nested class, it will run before each and after each unit test of that nested class only. Alright, now that we have briefly covered these 6 annotations, let's see what will be the output of running the unit tests. So we got our log, and we are going to output a little bit of a message within the log, and that way we can see ourselves the sequence of the invocations of these methods. Let's go. So end builds, and it builds not very fast, but it's okay for our purposes. Alright, let's see. So first, obviously, we got the message within the addBeforeAll annotated method. Then we are going to see that we've got the invocation of the beforeEach method. Then we can see that we've got the invocation of the beforeEach method within the isNotNull inner class. Now, for some reason, even though I have isNull in the first position, the isNotNull class is run first. Alright. And that is obviously because alphabetically isNull is in the second place to isNotNull, which is U is at a later position than O. Alright, and so we got the invocation of before each annotated method of in the isNotNull inner class. Then we've got the invocation of the add after each annotated method of the isNotNull class. And that's because basically we have run our add test annotated unit test method isNotNull underscore common underscore object underscore boolean. Now, what do we see next? We see next that after we run this unit test, the add after each annotated method of the top level class is invoked. Then we're going to see again the invocation of the add before each method of the top level test class, followed by the invocation of add before each method annotated method of the inner class isNotNull. Then we're going to see the invocation of the add after each annotated method of the isNotNull inner class, and then the invocation of add after each annotated method of the top level test class. And in that way, we have run both of these tests that are located in the inner class isNotNull. Next, our control passes to the isNull inner class, and this is what is going to start happening. We're going to see that add before each annotated class of the top level test class is invoked. Then we are going to see that the before each annotated method of the inner class isNull is invoked. Then we are going to see that the add after each annotated method of the inner class isNull is invoked, followed by the add after each annotated method of the top level test class. And that means that we have run our third unit test, and we're going to the running of our fourth unit test. And let's see what happens there. And again, we see that we are invoking the add before each annotated method of the top level test class, followed by the add before each annotated method of the inner class isNull, and then we're going to see that the next what is invoked after obviously add test unit test runs, add after each annotated method of the inner class isNull, followed finally by the add after each annotated method of the top level test class. And last but not least, having run all the 4 unit tests, we are going to see that the add after all annotated method of the top level test class is finally run, and that completes the running of our tests. So that is basically how this add before all, add after all, add before each, and add after each function at the basic level. One more thing I would like to mention. If you recall from our lecture, the top level test class, in our case objects tests, basically is instantiated anew for each new unit test. That's its default scope per unit test. Now, that is the reason why we must declare the add before all annotated methods and add after all annotated methods as static. However, if we change the scope of the objects test class to per class, that is, it would be instantiated only once, run all its unit tests, and then be completed, then we could forgo the static modifier and just make the add before all and add after all methods instance methods. But that is something you don't usually deal with in the simple test cases, which are going to be 95% of your unit testing. But it's just nice to know that the JUnit runtime gives you an option to vary the lifecycle scope of the test classes, and consequently you have some options regarding the application of the add before all and add after all methods. So we have completed our objects tests test class review as it applies to the add disabled, add test, add before all, add after all, add before each, and add after each annotations. And we're going to go in the next clips and add 4 more test classes, just like we did in the first lab. And we're going to review once again the application of these methods. However, it is the same as it is in the objects tests class. But what we are going to do, we are going to retype these annotations so that we are going to memorize how to use them. Thank you for your attention for the first test class, and in the next clips, let's go on to the 4 of the next test classes. So in this next clip, we are going to walk through the strings tests test class, and for that we are going to create strings tests Java class, and we're going to delete the automatically generated content within it. Then we're going to go to the course website, go to unit test code, string test Java labs 2. We're going to skip unified diff. This is only for our information of what's new. And we're going to copy the full file. Right, and we're going to do Ctrl V. And now we have the full file of strings tests test class with the additions that we need for lab 2. So in the next clip, we're going to explore the add before all, add after all, add before each, and add after each. And in exploring them, again, we're going to retype them. In objects tests test class, we did the explanations of what they do, and in the following classes, we're just going to go line by line, and we're going to retype Anywhere we see it before all, at after all, at before each, at after each, etc. See you in the next clip. In this clip, we're going to review the at before all, at after all, at before each, at after each, at test, and at disabled annotations by retyping them. So let's get started. We can start with the method static void setup all. Then let's proceed to static void tear down all. This lab is relatively simple, but don't let the fact that it's relatively simple tune you out. You should be attentive and please follow me in retyping everything. Alright, so we have completed retyping the at before all, at after all, at before each, and at after each for the test class level methods of that ilk. Let's go and now retype before each and after each for this nested class at least. I apologize, sometimes I type insert, which is located right next to other buttons after each. Alright, I'm going to retype the at test annotation a few times. This is obviously just to maintain the manual memory, which is the most important and best kept type of memory for most people. Some people are good with visual memory. I'm good with visual memory, but doing, overseeing for me is still better. Alright, at test. At test. I'm gonna retype at test a few times. At test. Okay, I'm gonna stop at 5. I think I retyped 5. Alright, and let's go on to the next nested class and let's do a couple of at before each, at after each. Let's go to the next nested class. Let's do at before each. At after each. Alt F7. Where are we? All right. Let's go to the next one. Let's do at before each, at after each. already. Let's go to the next one. And this will be the last add before each and add after each that I will type. So mostly what we are doing for these labs, we are learning by doing, which is the best way to learn. Concat tests, we have the same thing. Now we need add before each and add after each for the inner class, only if we want to add a certain processing before each and after each of that inner class's unit test methods. We could also, believe it or not, I believe we could also have add before all and add after all for an inner class, but then we would have to vary the scope of the inner class. All right, replace tests, add before each, add after each, replace tests underscore underscore one, add before each, add after each, and we are done. All right, set up all, tear down all. Let's do a couple of times more so that we memorize. And let's do one more time. Just repetitive behavior can cause accelerated learning. All right, and we are pretty much done with the maths tests class. We are with the strings tests class. So we are going to go to the maths test class next, but first let us make sure that strings tests pass. This is also a habit that we have to get into, to always check in passing unit tests. Alright, and I can see already that we are good to go, and we got lots of our login that we reviewed in the previous clip, in the clip prior to the previous clip. Alright, we are good to go, and I will see you in the next clip. In this brief clip, let us click on the test package name, select Java class, type in maths tests. Then let us delete everything that's auto-generated. Let us go to the project website. Let us go to unit test code, maths tests Java, lab 2. Let's briefly review unified diff, skipping it. Go to the upper right corner of the full file code box, click copy. Go back to IntelliJ IDE and click Ctrl V. Alright, we have in fact copied our maths tests test class, and in this particular one, if you notice, our nested inner classes do not have any add before all, add after all, add before each, add after each methods called lifecycle methods. Instead, all the four methods are only concentrated in the beginning of the test class. So what we're going to do, we're going to review them and retype them. We're going to retype add before all. add after all, add before each, and add after each. And I'm going to do a couple of tests, just for good measure. Add test. Remember, doing repetitiously is the basis of best memorization. Alright, and we're done. Let us run. Well, as you can see, there are no more lifecycle methods. I'm going to scroll rather quickly through additional inner classes. So for this test class, the reason inner classes do not have lifecycle methods is because the author of the test class, let us assume, decided that inner classes unit tests do not need anything that runs before and after them, in addition to top level test classes add before each and add after each, which already run before and after each and every unit test, whether located in the top level class or in all the inner classes. Alright, let us run mass tests. And if my memory serves me right, we have a little bit of a problem where we need to change one unit test's primitive data type to double. But let's see if we get any errors. Alright, there we go. In here, if you recall from the lab numbered 1, we had a problem where we needed to produce a double, and our assert equals method is very much overloaded, and what it does actually, it converts it to the wrong data type. Let's do it like this. This is a good example of things going wrong, and it's good to see that things can go wrong even in a, if you will, a lecture, and how to fix them on the fly. Let us try mass tests one more time. Alright, and they all pass, producing not a copious amount of login as strings tests class, because we had many more lifecycle methods in there that we chose to kind of indicate by implementing some login statements. Right, everything looks good. Let's see that all of our unit tests now pass as a habit. Alright, all 130 of 130 unit tests pass. Our maths tests unit tests pass just fine after we've corrected this minor issue. And in the next clip, we are going to go to collections tests test class. In this clip, we are going to go to collections tests test class. Let us first create the Java class named collections tests. let us delete what is auto-generated. Then let us go to our project website, collections test.java, lab 2. Let us briefly review the unified diff. We can see that there are only 4 lifecycle methods, like the previous class. Collections test class also chooses not to implement lifecycle methods for its nested inner classes. And let us go to full file. Let us click copy. And let us click Ctrl V, pasting this file into our IDE. Let us Ctrl V. Let's see. Okay, it does it. Good. Already. Now let us take a look at the collections tests lifecycle methods, and yes, let us retype them. So static void setup all is annotated with add before all. Let us retype it. The static void teardown all method is annotated with after all. Let us retype it. The void setup method is annotated with that before each. Let us retype it. And add after each embellishes and beautifies the void teardown method. And let us retype it as well. Alright, and all the other inner tests chose not to implement any lifecycle methods. Really, it is up to you, the test method writer, whether you need or not additional lifecycle methods. Now remember, I want to repeat something that I mentioned previously. A nested inner class ordinarily cannot support add before all and add after all lifecycle methods, except we have this nifty feature to be able to vary the instantiation behavior of both top level test class and a nested inner class. And so if we specify that our inner class would be set to lifecycle per class, then we could use add before all and add after all annotated lifecycle methods, and we would not need to make them static. We could just use instance methods. All right, let us see that our collections tests pass. That, by the way, I want to revert to what I just said. That we will explore when we will explore the annotation that controls the test classes instantiation behavior in a later laboratory. All right, let's try to run collections tests. And all the 42 of them pass. Let's run all the tests. And all of our unit tests pass, with all the login that we expect from the login statements we chose to place in our lifecycle methods for all the test classes that run from objects tests to strings tests to maths tests to collections tests. In the next clip, we're going to explore last but not least arrays tests, and that will conclude Lab 2. It is a relatively short and pleasant to pass lab. Unfortunately, Lab 1 had to be so arduous because there is a lot of material. In the Lab 2, we have the luxury of shortening it, and then we'll go to Lecture 3 after the next clip. Alright, we're almost done with lab number 2. Let us create a new Java class called Arrays Tests. Click Enter. Delete what was auto-generated. Go to the class's website. Go to unit test code, arrays test Java, lab 2. And let us review unified diff. Unified diff shows that we chose to implement lifecycle methods only for the top level test class. Then let us go to full file. Let us copy it and let us return to IntelliJ IDEA and let us press Ctrl V. Right, we have pasted the arrays test file. So as you can see, we are not implementing any lifecycle methods for nested inner classes. And we're only implementing them for the lifecycle methods for the top level class. Let's retype before all. Add after all. Add before each. Add after each. Alright, and we'll do a couple of tests as well. Let's do 3. Alright, test. And for the fourth one, let us additionally annotate the test with @disabled. Right. So let us go forward and let us run arrays tests test class. And let's see what happens. All of them should run with the appropriate login, except for the one which we annotated @disabled. All right. We can see that 41 passes, 1 is ignored, 42 total. Let's go to the one that is ignored. Okay. It is the one called public void is empty underscore special underscore array underscore boolean underscore underscore 1. Let us do now the typing and retyping of the disabled annotation. All right. Let's do it several times. Just using the fact that we want to memorize how to type all of our annotations. All right, and we're done. Now, for good measure, let's comment it out, but not delete it, so that it's there somewhere in the back of our mind. And let's retype now. Let's rerun now arrays tests. All 42 of our 42 tests pass, and we're good to go. So always check that all of your unit tests successfully pass before you check anything into version control. Let's do so now. We have 214 tests, and all 214 tests pass in just over 4 seconds. Wonderful. This completes lab number 2. Congratulations on sticking with the lab program so far. And please do not stop. Labs 3, 4, 5, 6, and 7 await. And next, we're going to lecture number